We did in class.
We did the one in
Hydroxide peroxide can decompose water and oxygen by the following reaction.
Do you have the picture?
Yeah, I tried, but.
Oh, okay. Okay, hydrogen, okay. Let's see. The question says that hydrogen peroxide the value of G.
Can you read it from the book first?
When 5 grams of H2O to decompose, the value of heat, I guess, the value of H maybe. This one. I guess it should be, here on the picture, anybody? I think it should be H. Okay.
No, right, wait.
That's the value of H, delta H, I guess, right? Should be.
It's in the book.
Okay, let's think about that.
Let me see.
The value of what?
No, calculate the quantity of what?
No, after that.
Read the whole statement for me, Beverly.
It says hydrogen peroxide can decompose to water and oxygen by the reaction, and the reactant is 2H2O2I, and then with the arrow 2H2OI plus O2G, and then that heat element equals 196 kJ.
Mm-hmm.
And then after that, it says calculate the quantity of heat released when,
The quantity of heat.
calculate the quantity of heat released
Okay.
when 5.00 gram G of H2O2, and then that sign I, decomposes at constant pressure. Not giving the answer.
Right?
Yes.
Okay. Okay. Thank you. Hydrogen peroxide can decompose to water and oxygen, and the reaction is given to you here. When it decomposed, it produced this much heat, 196 kilojoules of heat. That was given to you. Okay. Now, you need to calculate the quantity of heat released if 5 grams of hydrogen peroxide decomposed in the same way, like here, but at constant pressure. This gives you a guarantee that whenever you see or whenever you heard constant pressure, we're discussing about enthalpy, process of enthalpy, right? Now, how do we solve this problem? That first of all, this equation is a decomposition reaction, but also it's a thermochemical reaction. thermochemical reaction.
You have to convert the grams of H2O2 to moles first.
You can do that. You can do that if you want. Which gram? You're talking about 5 grams here?
Yeah, 5 grams.
Okay. How do you convert 5 grams of H2O2 to moles? You can do that, yeah? Yes, Tosi. How do you convert 5 grams of H2O2? You need the formula weight of H2O2. What is 1 mole of H2O2? 1 mole of H2O2. What's 1 mole of H2O2 equals to? So atomic weight of hydrogen and the atomic weight of oxygen.
34 grams.
4 plus 32, that is 34, right? 34 grams. Do everybody agree with that?
Yeah.
Okay. So if 1 mole equals to 34 grams, then we have 5 grams of H2O2. It's going to be how many moles? So we can just say 5 grams of H2O2 times 1 mole over what? 34 grams. Good. That gives you, I'm sorry? 0.147. 0.147 what? Moles. Moles of what? H2O2. H2O2, right? So, now this is what you're going to say. Okay, up to this point is clear, right? Right? Okay, now this is what you're going to say. You know, 1 mole, 2 mole of H2O2 generates 196 kilojoules of heat, according to this equation. According to this equation, according to the equation we have, every 2 moles of hydrogen peroxide decomposed, it generates this much heat. Okay, if that is the case, then we have 0.147 mole of H2O2 will generate how much heat? How much heat? This is how you set up the problem. Now you set up the problem like this. The next step is going to be basically crisscross. Okay? To find X, you can continue from here. X will be 0.147 mole of H2O2, right? Times what? 196 kilojoules over what? 2 moles of H2O2. Okay? So that's how you set up the problem, and you can solve the problem like this. And it gives you, I'm sorry? 14.4 kilojoules of energy will be produced if 5 grams of H2O2 will be decomposed. You can say that. Still, you can say, I'm not going to take off any point if you don't say negative. We know what negative means, right? It is released. Yeah, the best answer is negative. It means that it gives away. It means that the reaction is exothermic. That's what it means. Okay? Is that clear? Everybody has a clear understanding? Yes.
How do we know? We have to convert to kilojoule or just joule?
This was given, let's see, the question is how much, calculate the quantity of heat released when 5. Basically, it was given to you 196 kilojoules, right? So obviously you have to think, you have to take your intuition. Unless it's not given to you, if this was given in kilojoules, what do you expect? It should be in kilojoules, right? Unless you are instructed to do otherwise. Okay? But in some cases, I would say, calculate the quantity of heat released in kilojoules, or calculate the quantity of heat produced in joules, or calculate the quantity of heat produced in calories. Okay? Because we know that 1 calorie, if I don't make a mistake, is 1 calorie is 4.184 joules. Is that right? Yes?
Yeah.
Is that right? Okay. So let's say that you, if I want the answer in calories, what do you do? Let's say I have 14.4 kilojoules of heat. Once to change to calorie, what do you do? What's the first thing that you need to do? Change this to joules. Change this to joules. Then change it to calories. Kilojoules to joules. How do you change that?
Times divide to, times 1,000.
Times 1,000. You have to multiply by 1,000 because 1 kilojoules equals to 1,000 joules. Okay? So you're going to multiply this by 1,000 and then you're going to convert this by using joules into calorie by using conversion factor here. 1 calorie equals 4.184 joules. Does that make sense? Yes? Okay. Okay. Let's move to the next step. Okay, we're going to discuss about heat capacity and specific heat, and in this case we're going to introduce about the instrument called calorimeter. Okay, you know, heat flow, measurement of heat flow from one substance to the other is measured in calorimeter. The hotness or coldness of a substance can be measured by using thermometers, right? You can use the Celsius or Fahrenheit or Kelvin. I just want you to introduce you about a little bit in experiment 28. Those of you who were in experiment 28 last time. Okay. What did we do in experiment 28? What did we do in experiment 28? Brandy can answer me that question. I'm pretty much sure for that. You remember the cap we had, styrofoam cap? You were there too, right?
Oh, yeah.
Just the day before yesterday, on Monday.
Yeah. And a thermometer.
And then we add thermometer in it. What is that tells you? In fact, it's going to be an exam next week. Explain about the calorimeter. What we done in the lab. Okay? It's a part of your exam. That's a calorimeter, right? The cup that you're using is a styrofoam cup, right? Why you pick a styrofoam cup? Let's have my coffee today. Yeah, it is like insulated. It keeps you heat, right? Inside the calorimeter, you have a temperature, right? You also can generate heat by mixing acid and base. You had, I believe, you had sodium hydroxide there first, and you had 20 milliliters of sodium hydroxide, and you add another 20 milliliters of hydrochloric acid. By doing that, what's that you did? You are generating heat. You are generating heat. How do you know you are generating heat? How do you know? The thermometer inside that styrofoam cup is rising up. It's rising up. If you closely watch the thermometer, it rises up. That means that reaction is heat of neutralization. Okay? And then you are constructing your own calorimeter. So you're measuring the heat flow. You're measuring the heat flow that is generated from hydrochloric acid and sodium hydroxide. That heat flow is calculated by a formula known as the heat loss. You can't see it. That heat flow is measured by this formula here: specific heat times the grams of the substance times it should be delta T actually, change in temperature. Okay, I'm going to write that formula maybe here.
We'll say Q says.
I'm sorry.
We'll say Q.
Q is it's an abbreviation. It's an abbreviation for the heat loss or the heat gain of the substance. It is just an agreement. We just pick a letter Q for the heat flows. It can be heat loss or it can be heat gain. Okay, so basically we can just write here. Heat lost or heat gain, because you always have a situation. It can be heat lost, you mix with cold water with hot water, the cold water is gaining heat, the hot water is going to lose heat, right? So the process is vice versa, okay? So heat lost or heat gained, technically most literatures prefer Q equals to M times E times delta T, which is M refers to mass, C refers to specific heat, okay, delta T refers to difference in temperature. Difference in temperature. This is the basic construction how calorimeter is made. This is a basic formula how calorimeter is functioning. Okay, so you have M, you should know the mass, you should know the specific heat capacity or C. Specific heat capacity can be calculated by dividing the heat, if you know the heat loss or gain, Q over M times delta T. Okay, this is the formula for specific heat capacity. Specific heat capacity means the heat raised to measure 1 gram of the substance by 1 degree centigrade or by 1 degree Kelvin, doesn't matter, because we're taking the ratio. How much heat is raised to measure the temperature of 1 gram of a substance by 1 degree centigrade, that's called specific heat. And the interesting thing that you should know is specific heat every substance has their own specific heat capacity. Water has its own specific heat capacity. Aluminum or iron or copper or sand, oil, whatever, different materials have different their own specific heat capacity. So whenever you do calculate the heat loss or the heat gain of substance, the specific heat of the substance will be given to you. Okay, how much heat is lost or how much heat is needed to raise.
That's the formula for specific heat.
Yes, it's right here. Yeah,
What's that formula?
that is the formula for specific heat capacity.
Okay.
C is the ratio of the heat loss or the heat gain over M times delta T. Actually, if you know this, you can derive this. This is a derivation. This is the original formula here, and this
Which one
right.
are you going to use?
Pause.
But you would be given the Q value then, if you were.
If you have to be asked specific heat, the Q value must be given. Okay, the Q value must be given. William.
No, I'm not raising my hand.
Okay. Let me give you an example. Maybe that might. Yes.
Difference between the heat capacity and the specific heat.
In most cases, they are the same. It's the same. I mean, there is not any difference. But sometimes you'll be asking, what is the heat capacity per mole of the substance? That's the difference. Per mole. That means.
To raise this temperature by 1 degree for 1 mole of the substance.
Yes. But you see, so you may have a reaction. NaOH reacts with HCl, gives you NaCl plus water. And this generates some kinds of heat, general, right? But you may be asked to find what is the contribution of NaOH in generating the heat, the molar capacity or the heat capacity of NaOH, okay, or the heat capacity of HCl. Then you have to divide whatever heat, let's say if this gets like 540 kilojoules of energy, that's the whole process. That's the whole process. But what will be the share of NaOH, okay? You need to divide by the molar capacity of NaOH.
How do we know that, the molar capacity?
Well, that will be given to you. You have to calculate the mole, okay? You have to calculate the mole. What will be the mole? And you divide this by the mole of NaOH. That's called the molar capacity. If you have a question like that, I can give you some example from the textbook, but that can.
Professor, can you give us a direct question? Like, could you do a question now where the formula is concerned?
Yes, that's what I'm about to give you right now. I'm looking for the from the textbook to just exactly to fit this question. Okay, there. Maybe that might not be. Okay. Okay. Here's a good example. Sample exercise 5.5, page 176. Okay, page 176. How much heat is needed to warm 250 grams of, you have the book, how many if you have the book with you?
What exercise is that?
It is sample exercise 5.5. Sample exercise 5.5, page 176. In the new, you have the old one?
Same thing, page number.
Okay, page number is 181 if it's in the old textbook, you have the old textbook. Okay, let's see. Okay, how much it is needed to warm 250 grams of water from 22 degrees centigrade to 98 degrees centigrade, right? So, if you want to warm 250 grams of water from 22, from here, to 98, heat is added, right? There must be some kinds of heat added. So that is how we are measuring, okay? The thermometer provides you just, it was 22 degrees centigrade, but it's getting it to 98. It's a heat flow. How much heat is flow, how much energy is needed to warm up or to raise the temperature of 22 to 98. That is something we're going to use about heat gain, right? Heat gain. which is Q, okay? Heat has to be gained. So it's like the system has to gain some heat. By saying that, this is a process of endothermic. Okay, because heat is flowing into the system, right? Just think about that way too. So that's going to be M times C times delta T. Right? Do we know the mass?
Yes.
We know the mass. What is the mass?
200.
250. Do you know the specific heat capacity of water?
1.18.
Yes, the specific heat capacity of water is given to you actually. 4.148 joules gram per degree centigrade. That means joules, the gram per degree centigrade. This is joules.
Where do you get that?
That's given. That's a constant value. This will be given to you. Means to say that to raise 1 gram of water by 1 degree centigrade, you must have 4.184 joules of energy. Okay? It's a proportionality. To raise 2 grams of water by 2 degrees centigrade, you're going to double that. Okay? This is the specific heat for water. It doesn't work for the other material. Okay? So 4.184 joules per gram in centigrade times delta T. What's delta T refers to? 77. So you multiply this.
But it doesn't matter like all the
Where
like.
is it?
I'm sorry?
All the units doesn't matter. You just multiply all the numbers.
76.
How do you get the delta T?
You subtract 22 from 98.
Oh, it's 98.
76. Okay?
Professor, what's the CH then right here?
CH, what is that?
What is CH?
No, CH2O.
CH2O. This is H2O. The specific heat of water. Okay? Specific heat of water. Any question? Yes. That's your, okay. Oh, what's the answer then? What's the final answer if you multiply this? 79496? 794 joules, right? Right? And I have a witness.
79496.
79496.
Okay.
Okay.
79420.
Right answer.
That's 250 and then
So he
4.0.
doesn't agree with you.
It's 250 times 4.18
Times
times
76.
184. It's 184.
4.184.
4.184, yes.
Hey, where'd you get the specific heat of water? Where'd you get that?
No, the specific heat of water is a given value which has to be given to you.
Alright,
Okay, in a test or an exam, specific heat of each substance will be given. For water, it is 4.184.
alright, just wasn't given on the spot. I just was asking.
Okay.
Times 716.
Yes. This is 4.184
That's
times 76. Yes.
That's the specific heat.
Yes, for water. Okay, now let's see this. You done with this one?
No, I don't know where you got the 760 from.
99.
Minus 22.
Oh,
Okay, the difference in temperature.
okay.
Delta T means, what is delta T? Is T final minus T initial. The final temperature minus the initial temperature. That's what delta T is, right? Let me maybe, I don't know, don't have too much example here.
Professor,
Yes,
is there in any situation that we have to add the temperature?
we have to add.
Yeah, is there any situation that we have to add the temperature?
Oh, what do you mean add?
You know, in this kind of example we did now,
Subtract.
we subtract.
We subtract. No, we always subtract from the lower to the higher temperature. We're not going to add the temperature.
Oh,
We're not going to add. I think maybe
I'm
you
just
may have.
asking if there's any question that we have to add the temperature.
I have to read. I have to read the problem. Okay.
Or will you give us?
I have to read that problem. Maybe you may have a situation like this. You may have. I think you may ask this question. Maybe it's related with the lab work. I don't know. You have. Let's say you have cold water here. right? Maybe like 25 degrees centigrade. You have hot water here, hot water, which is maybe 98 degrees centigrade, right? You're going to mix the hot water to the cold water here, right? You're going to mix the hot water to the cold water. And your temperature is going to be between 25, between these two. Okay? So the question is, we're not worried about how much heat, what's the difference in temperature, but how much heat is gained by cold water. The cold water will gain heat. The hot water will lose heat, right? So we're going to measure the loss or the gain of heat, okay? One of the law of conservation of energy says that the law of conservation of energy is that the amount of heat lost by hot water has to be the same as the heat gained by cold water, okay? Which means like Q of cold water is the same as Q of hot water. So we're going to calculate the average temperature here. What will be the temperature? We have to specifically say that when you mix 98 degrees centigrade to 25 degrees centigrade, cold and hot water, what will be the final average temperature? The heat lost by cold water is obviously mass of the cold water times specific heat of cold water. Specific heat, as far as it is water, it doesn't change, right? Times delta T. Now in this case, delta T is going to be the average temperature, TAV, because that's the final temperature.
Yeah.
Right? The average temperature minus the temperature of the cold water. That is for the cold water here, right? And it's going to be the same as the heat gained by hot water, which is mass times hot water. The mass may be different. The mass here is different. The mass of hot water is different than the mass of cold water. Okay, so specific heat is the same, and delta T, difference in temperature, is going to be what? It's going to be 98 degrees centigrade, because that's the highest temperature, minus the average. So you have an equation here. I'm not going to solve the whole problem, but that way you can see, maybe you can add or you can divide. But here is the way we can say. The way we can say the problem is, maybe I want you to complete this by Friday, okay? I'm going to set the problem here. Heat lost by cold water is equals to heat gained, heat lost by hot water, right? Heat gained by cold water, right? Heat lost by hot water, mass of the hot water, times specific heat of the water, times difference in temperature, 98 degrees centigrade, minus the average. Heat gained by cold water is going to be mass of the cold water, specific heat of the cold water, times T average minus 25. So what is the unknown here? Do you know the mass of the hot water? You know it. Mass of the hot water, let's say, would be like 50 grams, okay? Specific heat is 4.184 joules, right? Times 98 minus T average.
What's the T average?
T average is when you mix the hot water and the cold water, you have one average temperature.
Professor, please, is this the continuation of the question given or?
No, this is a new one.
Okay.
This
So
is.
you are assuming the.
Yes.
You are assuming the
Yes,
value.
here is the thing. Okay, let me give you a picture, Lucy. You have hot water on this beaker, 98 degrees centigrade, hot water. On this beaker, you have cold water, which is 25 degrees centigrade. I ask you to mix them up. Now my interest is how much heat is flowing when you mix a 98 degree centigrade hot water to a 25 degree centigrade cold water. How much heat? How much temperature? No. How much heat is flowing? Temperature, you don't need calculation, you have thermometer. Correct. But how much heat is flowing from hot water to cold water? Hot water lose energy, cold water gain energy. That flowing, that kinetic energy, that flowing can be measured by using this. Okay? So, let's say the mass of cold water will be 30 degrees centigrade. The specific heat of cold water is 4.184 joules times the T average minus 25. Okay, I want you to finish this up for Friday. Yes.
Yeah, how can you tell like what's going to be?
So what you're saying is that's supposed to equal out when we throw it out there?
Which one?
That's supposed to equal, they're supposed to equal.
They have to be equal, of course.
What's the mass of the cold water?
Sorry? Sorry.
So mass is different, mass is 30 for the student.
Yeah, write this down. Mass of the cold water is 30, mass of the hot water is 50 grams. I'm giving you now. Because the mass can be anything, the mass can be different, yes.
150.
You said
Mass
mass
of the
of
cold water is 30.
Mass of cold water is 30 grams. Mass of
Specific heat.
hot water is what? 50 grams. Specific heat of water, regardless whether it is cold or hot, is 4.184 joules. Calculate the T average. The average temperature. Average temperature means when you mix the hot and the cold, they have one average temperature, right? It was 98 degrees centigrade. On this side you have 25 degrees centigrade. You mix them up. The temperature would be between 98 and 25, right?
So we would
We don't know
add,
exactly what.
so we would add the two temperatures and divide by 2 to get the average, right?
This is a formula that will be very easy. That is, you don't need this. You don't need this. It is really, it's like.
Hey, what's under joules in that fraction? What's that?
Over here,
Yeah, what's that?
joules, and gram, degree centigrade. That means the unit of specific heat is going to be joules over gram per degree centigrade. Joules over gram per degree centigrade. That is the unit of specific heat. So, we're going to continue this on Friday, okay? And then we can wrap up chapter 5 on Friday. And I'm going to start reviewing chapter 5 on Friday. Come on Friday.